Sand mold casting, also called sand casting, is the most common casting process. It is applicable to a great variety of metals, and there is essentially no limit to the size of casting that can be made. Castings made in sand molds are not very precise, but production cost is generally lowest. Although the molds are expendable, the sand can usually be reconditioned for reuse. Sand molds, made in halves, are built by tightly packing the sand around the pattern in a flask. The upper mold half is called the cope, and the lower half the drag. The mold includes one or more risers, venting provisions, and a system for transferring the molten metal to the mold cavity. This system includes a pouring basin, sprue, runner system, and one or more gates. Once the sand has been compacted, the pattern and mold half are separated, and any loose sand is blown away. Cores, if required, are inserted into the mold. Once they are set, the mold is closed by aligning the cope and drag. The mold is then transferred to the pouring station. In casting, metal flows from the pouring basin through the sprue, runners, and gates to the mold cavity. Vent holes formed in the cope and drag, and often in the cores, permit trapped gases to escape. After filling the mold, the metal enters the riser or risers, which serve as reservoirs of excess metal to compensate for metal shrinkage during solidification. Once cooled, the casting is removed from the mold, and the metal in the runners and risers separated from the casting for remelting. Casting in sand molds is classified based on the type of sand used and variations in the mold-making process. These variations include casting in green sand molds, no-bake molds, and in shell molds. Green sand molds are made from a flexible mixture of silica sand, clay, and water. The sand is said to be green because of its moisture content. Although casting in green sand molds is a versatile process, thin sections are difficult to cast because they may be eroded by the molten metal, or the metal may cool and become solid before filling the sections. Also, part tolerances and machining allowances must be rather liberal. Very smooth finishes are not attainable, and certain metals can develop defects if cast in molds that contain moisture. Investment casting is a precision process using primarily ceramic shell molds. Investment casting is also known as the lost wax process, because wax, a principal pattern material, is consumed during the mold-making process. Consumable plastic patterns are also used. Investment casting patterns are made by injection molding. These patterns are assembled onto a wax post connected to a pouring cup. This pattern assembly, called a tree, usually incorporates complex runner systems to assist metal flow in the investment casting process. The shell mold is produced by dipping the pattern assembly several times in slurry and allowing it to dry between dips. The first slurry mixture consists of fine particles for smoothness. Subsequent dips are mixed with coarse particles to quickly build up thickness and provide strength. The wax is removed from the mold by melt-out in a furnace or autoclave. Then the mold is fired to remove moisture, cure the ceramic, and to preheat it for pouring. Both ferrous and non-ferrous metals can be investment cast. Once the metal has solidified, the mold is broken and the casting removed. The main advantage of investment casting is the complexity of shapes that can be cast to close tolerances, thin walls, and smooth finishes. Most investment cast parts weigh less than 4.5 kilograms. However, parts weighing over 100 kilograms are also made. Evaporative foam casting refers to the use of expendable polystyrene foam patterns in molds made of dry, unbonded sand. The process is also known as the lost foam or expanded polystyrene process. The pattern may be a single piece, or for complex shapes, an assembly of molded pieces. Patterns also can be clustered in groups to produce multiple parts at a time. The pattern is coated with a thin, high heat-resistant coating, usually silica. Once the coating is dry, the pattern is placed in a flask and surrounded by sand, which is vibrated for compaction against the pattern. Casting then proceeds with the poured metal evaporating the polystyrene foam and filling the cavity formed by the pattern.